Hello everyone. In this specific video lecture, I'm going to talk about generating a CPS using state space modeling or space state modeling. So we are going to talk about uh, model-based approach for CPS. So I had given you two examples. One was traffic light, and the other one was, I think, door lock automatic. So these were the two exercises that were given to you, to help you practice with the state model. We'll see both the examples. I'll just touch upon, how to start, how to approach, how to define, and how to go with the state modeling. Now, the reason why I'm doing this is when I look through all of your assignments, they were pretty good, but still there were certain assumptions that are taken for granted, which should be explicitly mentioned, otherwise it will not work. So to touch upon that particular aspect, which will also be useful towards your exam, I thought I'll do these two examples. So first, let me start with traffic light. So first, as discussed, the first approach should be is defining your system, or in other words, system requirement. So under that, if I have to define my system, I'm going to have three stages: red, green, and yellow. These are my three states: red, green, and yellow. Then I need to define the trigger points, trigger point or signal or event. That is when the system will transition from red to green, green to yellow, or whatever. Okay, now as far as this traffic light is concerned, there can be two ways by which you can make the state transitions happen. One is a very simple technique called time. So it stays in a particular state for a particular time. Once the time is up, it shifts to the next. It's one of the most simplest. But is it the most optimized? I do not know. Maybe, may not be. The second method is by visual cue. So what do I mean by visual cue? QUE is nothing but if you have a camera, it's a 4-cross junction. You have four cameras looking at all possible roads, and then you write an algorithm to identify the number of vehicles which has got red or green or yellow. Based on that, you switch. So that's called visual cue. Now, this can also be done, but this is more complex. Remember, I don't know how many of you have seen, very few people have seen the videos, that's for sure. I can see with the number of views. In that model based approach, I would have told you if you have a lot of assumptions, the models will become a lot simpler and easier to construct. On the contrary, as you bring in more optimization, the model gets more and more complex, or when you bring in more reality rather than assumptions, the model becomes complex. So these are the two ways. Since we don't have a visual cue right now, I'm going to go with time as the trigger point or event or signal for transitioning from one state to the other. The next thing that we need to identify is the sequence. What is going to be your sequence? So in order to establish sequence, we need to assume certain things. So my assumption is the initial state is red. Now, is it mandatory to always observe or always assume that the initial state is red? No, you can have initial state as green, you can have initial state as yellow, up to you. Based on that, it's going to change. So my assumption is the initial state as red. So I have my red. Now what are the other two states? The other two states are green and yellow. So can the sequence be like this? I don't think so. The sequence cannot be like this. It cannot be red to yellow, yellow to green. It can be, but in reality, if you see, is it not? But if you assume it this way and say, hey, my traffic light system is going to be like this, then agreed. But it should be logically convincing. You cannot assume anything. Okay. In that case, literally, if you see from red, it goes to green, and after that, it goes to yellow. Now, is this sequence right? No, again. Okay. Why? Because this is incomplete. So, what is the actual correct sequence? It is R, red to green, and then it stays there for a while, then green to yellow, and then it goes to red. So it's a closed loop. If you just leave it this way, it's wrong because the loop is not closed yet. Okay, so this is how the sequence is. And now that we have established the sequence and the trigger signal or the event as time, now we need to define something. I'm going to define TR, TG, TY. So this is the time in which it will stay in red, and this is the time in which the state will stay in green, and this is the time in which it will stay in yellow. So these are the three times. Okay, now what I'm going to do, I'm going to go with drawing the state diagram. So I'm going to have red, I'm going to have green, and I'm going to have yellow. We know there's going to be a transition from red to green. We know there's going to be a transition from green to yellow. And then we know there's going to be a transition from yellow to red. Under what conditions? When the time is greater than, it becomes greater than TR. So when the time exceeds the limit of TR, it transitions from red to green. Similarly, when the time is greater than TG, that is, it's supposed to stay in the green state for a while, that is called as TG. We defined it earlier. If you look at this, and then it transitions from yellow to red when time exceeds T yellow. Now this is what generally many of you have done. What you have assumed is it's going to stay in red, but it needs to be indicated. If I'm going to give this to a client, he knows it's going to go from red to green, green to yellow, or an implementation engineer, he knows it's going to go from red to green, green to yellow, and yellow to red. Okay, he knows the conditions of how to make it work. But what we are missing, what the thing is missing is, it is supposed to stay in red as long as time is less than or equal to TR. Similarly, it is supposed to stay in green as long as time is less than or equal to TG, and it is supposed to stay in yellow as long as time is less than or equal to TLO. This is something that we often miss. Of course, in today's signals, we see an LED display or an LCD display indicating the timer left on that particular state. So if you want to add that, it's pretty simple. Probably you can tap it from here. Display. Where it's going to display how much time it has for red, how much time it has for green. But if you say, if the time for green and then you want to also display yellow, that is also possible. You can have this. So now you get the idea of how to construct a traffic signal based state diagram. it is very imperative that you mention all the things, the conditions, everything that's going to make this state, transit or stay there. That's very, very important. Okay. So with this, we have finished traffic light. Next video lecture, I'll talk to you about automatic door locking system.